With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Students, I hope you all are doing good. So today our question is like this. Predict the order of reactivity of the following compounds in SN1 and SN2 reactions. So basically we have different alkyl halides and we have to find the correct order of reactivity of these compounds. Okay, so our compounds are like this: C6H5CH2Br dot C6H5CH C6H5Br. Okay, we have other compound like this. So we have different compounds. Okay, so we have to determine the correct order of, we can say, the right order for the reactivity of these compounds. So first of all, we have to know that for SN1 reaction, 3-degree alkyl halide is more reactive than 2-degree alkyl halide and is more reactive than 1-degree alkyl halide. Okay, for SN1 reaction, 3-degree alkyl halide is most reactive and 1-degree alkyl halide is least reactive, or we can say it is unreactive. So to give the reaction by SN1 mechanism, 3-degree alkyl halide will be most reactive to give the product by SN1 mechanism. Okay, because in this SN1 reaction, that is unimolecular nucleophilic substitution reaction, in SN1 reaction there is two steps. In first step there will be formation of carbocation. So more the stability of carbocation, more will be the reactivity of the alkyl halide. So in case of 3-degree alkyl halide, the carbocation formed is 3-degree. Okay, carbocation formed is 3-degree. In first step there will be removal of nucleophile. There will be, or we can say there will be removal of nucleophile. Like in this case there will be Br removal, then there will be formation of carbocation. So in SN1 mechanism there is two steps. First step is formation of carbocation and the second step is attack of nucleophile on the positive carbon. Okay, so in case of 3-degree alkyl halide, there will be formation of 3-degree carbocation, and we know 3-degree carbocation is the most stable carbocation. So 3-degree alkyl halide will be the most reactive alkyl halide in this case. So the reactivity order, this is the reactivity order of alkyl halide. That is 3-degree alkyl halide will be most reactive, because in this 3-degree alkyl halide there will be 3-degree carbocation formed in the first step of this mechanism. Okay, so reactivity order of alkyl halide. So this is for SN1, and for SN2, 1-degree alkyl halide is most reactive, then 2-degree, and then 3-degree. So in case for a reaction or for alkyl halide to give reaction by SN2 mechanism, then 1-degree alkyl halide will be most reactive towards the SN2 mechanism, because this is a single step process. In this there is simple attack of nucleophile on the back of the carbon which have already nucleophile. That is, if we are wanting to give the nucleophilic substitution reaction on this compound, that is C6H5CH2Br, then there is simple attack of nucleophile on the back of alpha carbon. This is the alpha carbon because this carbon is attached to this nucleophile group, that is Br group. So at this carbon there is a single step mechanism, and there will be attack of the other nucleophile on the back of the alpha carbon, and there will be removal of the leaving group will be there. Okay, so this is a single step mechanism, and this reactivity depends on sterical hindrance. More the hindrance, more will be the difficulty for the nucleophile to attack the alpha carbon. More the hindrance on the alkyl halide, on the carbon of the alkyl halide, then more will be the difficulty to attack the nucleophile on that alpha carbon. Sterically hindrance. Okay, now I will give you the correct order for these compounds. Okay, and I will let you explain also. Okay, so let us draw the compounds first. First we have C6H5CH2Br. Okay, we have first compound like this. This is the benzene ring, and we have CH2Br. We have CH2Br like this. I hope you are getting this. So let us name this compound as 1. Okay. We have second as C6H5CH C6H5Br. Okay. So we have C6H5. I am writing the molecular formula only. You can also draw the structure of this. CH C6H5Br. CH C6H5Br. So this is the second. This is the second compound we have in the options, or we have in the question. Third we have C6H5CH CH3Br. In third we have C6H5 CH CH3Br. I hope you can easily draw the molecular structure, or we can say the structure of these compounds. I hope you can easily draw the structure of these compounds. Okay. So we have the third structure like this. Now we have final structure as, wait a second guys, C6H5C CH3 C6H5Br. So this is the very basic structure. You can easily draw this structure. So it will be C6H5 C CH3 C6H5 and it will be Br. So are all the four compounds, all the four alkyl halides are like this. This is the fourth alkyl halide. As you can see, this is the 1 degree alkyl. This is the 2 degree alkyl halide. Sorry, this is the 1 degree alkyl halide, because this carbon is attached only with the one carbon, that is this carbon. So this is the 1 degree alkyl halide, because the carbon attached with the halogen, that is Br, is attached with only single carbon. So this is 1 degree alkyl halide. This is 2 degree alkyl halide. As you all can see, this is also 2 degree alkyl halide, and this is 3 degree alkyl halide, because this alpha carbon is attached with 3 other carbons. So it is 3 degree alkyl halide. Okay. Now you can easily find the order according to this order, that is 3 degree most reactive for SN1, then 2 degree, then 1 degree, and for SN2 1 degree greater than 2 degree, and then greater than 3 degree. Now we have to identify between these 2 degrees. We have to identify between these 2 degrees, that for SN1 which is more reactive. As I explained you earlier, SN1 reaction is based on the stability of the carbocation. SN1 mechanism is based on the stability of carbocation formed in the first step. So in this, if you remove this Br group in the first step, there will be removal, or we can say there will be removal of nucleophile and formation of carbocation will be there. So if you remove this Br group, then there will be carbocation formed like this. I am drawing it here. C6H5. In the first step, the carbocation formation, the carbocation will be like this. CH positive C6H5. Okay, so this carbocation will form in this case when this 2 degree or this second compound will form the carbocation, or there will be removal of nucleophile is there, then this carbocation will form in this compound. Okay, and in this compound, that is C6H5CH Br CH3, I am drawing it here. The carbocation will be like this. C6H5 CH CH3, and this is the carbocation formed. I hope you can easily see that there is more resonance. There is 2 C6H5 group, so there is more resonance than this compound, then this carbocation. There will be more. Wait a second guys. Okay, so this carbocation will have more resonance than this carbocation, because this carbocation is formed when this 2 degree alkyl halide, there will be removal of nucleophile in the first step, then this carbocation will be formed, and in this case that is C6H5CH CH3Br, the removal, first step is the removal of nucleophile, then this carbocation will form. Okay, so this carbocation is more stable, because there is more resonance in this carbocation, because we have 2 C6H5 group there and there is only one C6H5 group. Okay, that is phenyl group. So there is more resonance in this carbocation, so it will be more stable. So this carbocation will be more stable. So this alkyl halide, that is second alkyl halide, will be more reactive. Okay, because the reactivity of alkyl halide depends on the stability of carbocation. More stable the carbocation, more reactive will be the alkyl halide. So as you can see, there is more stable carbocation formed in this, so this will be more reactive alkyl halide. So now let us find the order of the SN1. So for SN1 mechanism, the reactivity order will be: third will be most reactive, fourth will be most reactive, that is fourth alkyl halide is like this, fourth compound is like this, C6H5, C6H5, CH3CBr. So this is our fourth compound, and this fourth compound will be most reactive because as you can see, this is the 3-degree alkyl halide. So fourth compound will be most reactive, then 2, then second compound, because I have explained you earlier that this will give us more resonance stabilized carbocation. This will give us more resonance stabilized carbocation. So this second compound or second alkyl halide will be more reactive. So it will be second, then it will be third, and then it will be first. First will be the least reactive because it is the 1-degree alkyl halide, and 1-degree alkyl halides are almost unreactive, or we can say very less reactive. So this is the correct order for SN1 mechanism. Okay, now we have to find the order for SN2 mechanism. Okay, so for SN2 mechanism, we know in case of SN2, 1-degree alkyl halide is most reactive because in 1 degree there is least sterical hindrance. Because in 1 degree there is less sterical hindrance, and this is and in the less sterically hindered alkyl halide, there is easy for nucleophile to attack the back of the alpha carbon. This is the alpha carbon in this case, this is the alpha carbon in this case, this is the alpha carbon in this case, and this is the alpha carbon in this case. The carbon attached with the halogen, that is alpha carbon. Okay, so in this we can say in the first compound, this is the alpha carbon and this is least sterically hindered. As you all can see, this is the 1 degree and this is least sterically hindered, or we can say this is least crowded. So the attack of nucleophile from the back, that is single step mechanism. BF-SN2 is the single step mechanism. There is basically simple attack of nucleophile from the back of the alpha carbon, because there is Br attached at this carbon in the forward side. Then nucleophile, that is, let us see, we are adding nucleophile, then this nucleophile will attack this carbon from the back like it. Okay, and then there will be removal of this leaving group and there will be attachment of this nucleophile, or we can say there is substitution of the nucleophile in place of this Br. Okay, so this is the single step mechanism in which there is attack of nucleophile on the back of the alpha carbon. So if this carbon, or we can say if this alkyl halide is 1 degree, then there will be least sterical hindrance, there will be least hindrance, then this is easy for the nucleophile to attack this carbon. In case of 3 degree alkyl halide, there are 3 big or we can say there are 3 big groups attached with this alpha carbon, that is 1 C6H5, 1 C6H5 and 1 CH3. So there are 3 other groups attached with this carbon in the 3 degree alkyl halide. So this is difficult for nucleophile to attack this carbon from the back, because these other groups will try to stop the nucleophile to attack this carbon. These other groups like this, these other groups will try to stop the nucleophile to attack this alpha carbon. So in the 3 degree alkyl halide, there is more difficulty for nucleophile to attack this carbon from the back. Okay, so in case of SN2 mechanism, 3 degree will be least reactive and 1 degree will be most reactive. Okay, now we have to identify between these two, because these two are both 2 degree. These two are, that is second and third, both are 2 degree alkyl halide. But as you can see, in this alpha carbon is attached with 2 C6H5 group, that is 2 larger group. But in this case, in this third compound, there is only 1 larger group, that is C6H5. So there is less sterical hindrance. There is less sterical hindrance. So there is comparatively easy for nucleophile to attack this carbon from the back, because there is only 1 big group, that is 1 phenyl group attached with this alpha carbon, and there is 2 phenyl group, 2 big groups are attached with this alpha carbon. So there is more difficult for nucleophile to attack this alpha carbon. So this 2 degree will be less reactive than this, because there is less chances of nucleophile to attack this carbon, because there is more sterical hindrance. So there will be difficulty for nucleophile to attack this carbon from the back, because they don't allow the nucleophile to attack this carbon. These two big groups, that is C6H5 group, these two big groups don't allow the nucleophile to attack this carbon. I hope you are getting this. So this second compound will be less reactive because there is more sterical hindrance. So there will be more difficulty for nucleophile to attack this carbon. So the correct order for SN2 mechanism will be 1 degree will be most reactive. That is, first compound will be most reactive. Then 2 degree. And in 2 degree, what will be the more reactive? This will be more reactive because there is less sterical hindrance. So there is comparatively easy for nucleophile to attack this carbon. So third will be more reactive than second, and then it will be fourth, because fourth is the 3 degree alkyl halide and there is very less chances for nucleophile to attack this carbon. So 3 degree is the least reactive alkyl halide towards the SN2 mechanism. So for SN2 mechanism, the correct order is first greater than third, greater than second, greater than fourth. Third is greater than fourth, third is greater than second, third is this compound and second is this compound, because in third there is less sterical hindrance, so it is comparatively easy for nucleophile to attack this alpha carbon and then form the product. So reactivity of this third compound will be more towards SN2 comparatively to this second compound. So this is it for this question, guys. I hope you are getting this. These are the two basic mechanism for or we can say these are the two basic reactivity order for SN2 and SN1 mechanism. I hope you are getting this. I hope you understand how we are finding the correct order for these compounds for SN1 and SN2 mechanism. Thank you, guys.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.